Hi there, Earthdines. We're going to look at another application of differential equations, and this one is Newton's law of cooling, which some of you might have come across in physics. And so Newton's law of cooling says that the change in temperature, that's what capital T is for, with respect to the change of time, is equal to some constant times the difference between the temperature of the water and the temperature of the room. And so in this example we have water in a saucepan at 70 degrees and it cools to 40 degrees in 5 minutes in a room at 20 degrees. It's asking us to calculate the temperature after 10 minutes. So let's write out the formula. So we have change in temperature with respect to change of time is equal to negative K temperature minus room temperature. So what we can do here is rearrange it and say dt is equal to negative K T minus 20, because that's the room temperature, with respect to little t, and then rearrange it so that we've got 1 over T minus 20 with respect to D temperature equals negative K dt. So now we can integrate both sides, and so we get natural log of T minus 20 equals negative kt plus c. And so taking the power of e of both sides, we end up with t minus 20 equals a e to the negative kt. So I'm going to leave that negative 20 there, but we're given some initial conditions here. So we start at 70 and the temperature in the room is 20. So that means that our initial difference is 50. So we can say that T minus 20 is equal to 50 e to the negative kt. And then we're told that 5 minutes later the temperature is down to 40, which means that T minus the room temperature is going to be 20. And so all of this here is going to be 20. So we've got 20 equals 50 e to the negative k, and that's times 5, so negative 5k. So we can say that e to the negative 5k is equal to 2 over 5, and natural log of both sides, I'll bring it up here. So then we're going to have negative 5k equals natural log of 2 over 5, and so k is going to be the natural log of 2 over 5 divided by negative 5. And that comes out as, in fact I think I've worked it out earlier, so there's a natural log divided by negative 5 is 0.183. So that means our model is going to be T minus 20 is equal to 50 e to the negative 0.183 t. So question's asking what's temperature after 10 minutes, so that means that we need to put 10 in for t. And so the difference is going to be 50 e to the negative 0.183 times 10. So t minus 20 is going to be equal to, so we need a calculator for this one again. So we will have, let's times that by negative 10, and then take e to the power of that, and then times that by 50. So our difference is going to be 8 degrees. So adding 20 to both sides, the temperature of our water is going to be 28 degrees after 10 minutes. Okay, so Newton's law of cooling is not used just for water, it's also used for other bodies that cool. And in fact, this is a very important tool used in forensic science for determining the time of death when a homicide body is being found. So very useful in real life. Have a look at 23.08 and see how you get on.